Okay, let's start with SIMD. In case of SIMD, we have a single machine instruction, and naturally this single machine instruction works on different processes. Now, how single instruction can work on multiple data? Suppose I want to multiply 4 and 3 as well as 5 and 6, as these two data sets are mutually exclusive, so it is absolutely possible to have these types of instruction. Now thing is that if we have number of processing elements more than this, the same instruction can be applied in that way. Now this thing is basically applied in vector and array processing. Why is it so? Because suppose I have a memory length from 4000 hex to 8000 hex, and right now the memory pointer is at 4000 hex memory location. In that case, what we have to do, suppose the value 4 is residing at 6280 memory location. So I need to move the memory pointer rightwards to fetch that value, and suppose the value 3 is at memory location 3200. So naturally I need to move leftward to fetch that value, and then only I can use that instruction. That's why we need the direction, and it is called vector processing. Now, in case of MISD, you already know that it is an impossible scenario. Why it is impossible? Because we cannot apply parallel instruction to a single data. Why is it so? This is simply because both of them will try to modify and use that data which is not permitted. That means only a single instruction will be able to get hold of that data and will be able to work on that data. Now, in case of MIMD, we have a set of processes and simultaneous execution of different instruction is possible. Why is it so? Because there are different processes, they are working parallelly, and as there are different processes, different instruction as well as same instructions can be applied. And naturally the data set also has to be different, because if the data set is same, then it needs to be replicated. That means it should have multiple instances. The NUMA, the class